All right, guys, today we're going to go over the midterm review sheet. If you can do these problems, you will definitely be able to do the problems on the test because they are a mirror image of them. All I'm doing is changing the numbers in the problems, okay? So let's go ahead and try this. First, we see the absolute value sign. Remember, whenever we see these bars, it means how far it is away from 0. So 4 is 4 spaces away from 0. -8 is 8 spaces away from 0. And then the plus sign is not in the bracket, so that comes down. Now we have 4 plus 8, and 4 plus 8 is 12. So my answer must be B. Next, I got number 2, -17 minus -3. We know from our class that if we have a parentheses, it means we're multiplying. So this is really like a negative times a -3, or some people remember there's always a 1 after the negative, even if you don't see one. So it's like a -1 times a -3. It's still going to give you a positive 3. Remember, you have to multiply before you're allowed to add and subtract according to PEMDAS. So you have to do this part first. Now you have 17 minus 3. That's like I borrow $17 from you, and then I give you 3 back. Well, that means I owe you $14. The other way to remember to do this is to remember that the signs are different. When my signs are different, I find the difference. That means I'm going to find the answer to a subtraction problem. In this case, I have the big number minus the small number, and then I keep the sign of the big number. So 17 is a bigger number than 3. Now I have the big number minus the small number. That's going to give me my 14. And then I keep the sign of the big number. The big number was 17. And that's how I got -14. As you can see, we get the same answer. So C will be the correct answer. Number 3, we have 8/9 plus 4/9. In this case, we know that as long as my denominator is the same, I'm allowed to add my numerators together. 8 plus 4 is 12. So this is simply going to be 12/9. Remember, we keep the denominator the same when we add. So D would be the right answer. Many of you will think, Mr. Mendes, shouldn't I have simplified this? Because this is a division problem. 12 divided by 9 will give me 1, with 3 left over, which will give me 3/9. And I could even break that down more to say that's 1 and 1/3, because I know that both of these are divisible by 3. But look, those possible answers aren't here. So in the case where you don't have a way to break it down, you take the answer that best fits it. None of these others even come close. Number 4, we got 4 1/5 minus 4/5. Once again, my denominator is the same, and I'm allowed to subtract, but I cannot subtract 4 from 1, so I have to borrow from here, or I could even turn this into improper fraction. Remember, I could say 5 times 4 is 20, and 20 plus 1 is 21. So this is really 21/5. And I could subtract 4/5 from it. And now I could say that 21 minus 4, let's see, that's going to give me 20 minus 4 will give me, I want to say 17. So it should be 17/5. Now that I got that, I realize that that's not one of the possible answers. So in this case, I will treat this like a division problem, because every fraction is a division problem. And 17 divided by 5 let's see, we've got 5 goes into 17 3 times. That knocks it down to A, C, or D. With 3, let's see, that's 15. That's going to give us 2 left over, right? Let's see. So that will give me, with 2 left over, that's going to give me 3 and 2/5. So 3 and 2/5, D would be my correct answer. All right. The other way I could have done this, if I chose to do it that way, is to say I'm just going to borrow one of these 5s by using one of from my 4. So in other words, this could be changed. This is equivalent to 3. And let's see, if I borrow a 5 from here and bring it up, that'll make 6 over 5. Minus 4 over 5. Now, as you can see, 6 minus 4 is 2, and that's where we get our 2/5 from. And we also know that 3 minus, well, there's no whole number here, so that would make 3. Once again, we get 3 and 2/5. All right, let's go to number 5. Number 5 doesn't have fractions with the same denominator, so I got to find the greatest common denominator. So if I was to do that, I realize that 5 could be multiplied to 3 to get 15. But if I multiply the bottom by 3, I have to multiply the top by 3. So this is really going to turn into 3 over 15 plus, that is an ugly plus sign. Let me change it before somebody thinks I made a variable instead. And now we have 2 times 3, that's 6. We have 5 times 3, that's 15. And now we can't go ahead and combine, add them because the denominators are the same. 3 plus 6 is 9. So this is going to give me 9 over 15. And 9 over 15 is not one of my possible answers. So what do? I remember I can go ahead and reduce both of these by dividing them both by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And so another way of writing this would be 3 over 5. And that is one of my possible answers. All right, number 6 says 4 over 7. I have to apologize for that. When I transcribed the problem over, it didn't put the multiplication sign in between, so I just added it. But now that we see it there, 4 over 7 times 4 over 7. Well, remember, when we're multiplying, we're allowed to take the top number to the top number and multiply the bottom number to the bottom number. 4 times 4 is 16. 7 times 7 is 49. So this is really 16 over 49, and we have that as a possible answer. Number 7, we got 2 over 5 divided by 3 over 5. Remember, when I'm dividing fractions, I have to use K of C. That means I keep the first fraction exactly the same. See, I'm flipping the second fraction, so it'll be 5 over 3. And I'm changing from division to multiplication. Now, some of you are saying, Mr. Mendez, you know darn well that I learned it as KCF. And if you want to use it as KCF, either way, it doesn't matter. You're going to use the same steps, okay? You're still keeping the first one the same. You're changing from division to multiplication. You're flipping the second one. So let's go ahead and work this now. We realize that when we're multiplying across, we're allowed to use the butterfly method. So in this case, I could cross out the 5's, and I know it would be 2 over 3. So I got 2 times 5. Either way I could do this. It would give me 10. 5 times 3 would give me 15. When I divide both by 2 over 2, it's going to give me the same answer. I'm sorry, a 5 over 5. I don't know why I put 2 over 2. That should have been 5 over 5. My apologies. That will give you 2 over 3. And the other way you could have done it, of course, is just use the butterfly method and cross these out, because 5 goes into 5 one time. So that'd be 2 times 1 is 2, 1 times 3 is same thing. So 2 over 3. Let's go to number 8. How is a constant term different from a variable term from an expression that represents a real world situation? Well, as it implies, a constant term is constantly the same. Okay, when it's constantly the same, it doesn't change. So that means my constant term, I'm going to write over here. And the second one says the changes in value whenever the value of the variable changes. Well, that variable right in the answer should have gave it away. This one will get put in here. Number 9, which expression is equivalent to the one below? Remember, we're going to combine like terms. I can't combine things that don't have the same variable to the same power. So I got to look for the things that are the same. These two have a's in them. So 5a, and then remember the term always starts with the sign in front. 5a plus 2a is 7a. And then these two have b's in it, and a negative 8b and a positive 6. Well, I'm combining two things that have different signs. When my signs are different, I find the difference, okay? So that means I'm to the answer to a subtraction problem. I take the big number, which is 8, minus the small number, which is 6. I'm going to keep the sign of the big number. So since these are b's, I have to remember to put that in my answer. So this is negative 2b. All right, so my answer should be 7a minus 2b. 7a minus 2b. 10 says, which expression is equivalent to the one below? This time we have a negative sign in front of a whole expression. Remember, this is like taking a negative and multiplying it to everything in here. When I do that, I'm changing all the signs. It's like a negative 1's being multiplied to everything. So the second term is going to go ahead and become the opposite, all the opposite signs. This would be a negative 2a. And since this is a negative 2b here, it will become a positive 2b. Now I can combine my like terms. Now I've gotten rid of all this up here. So 5a minus 2a, that's going to give me, well, 5 apples minus 2 apples is 3 apples. And negative 7b plus 2b, again, the big number is 7, small number is 2, so 7 minus 2 is 5. Now I keep the sign of the big number, so it's a negative 5b. 3a minus 5b should be my answer. Number 11 says use the greatest common factor to factor the expression below. Remember, I'm looking for the thing that's the number that's inside all of these, the biggest number. Well, if I was to take 6, I know 6 consists of, let's see, well, 1 times 6. It also consists of 2 times 3. So those are all the numbers that make up 6. Let's try 15 now. And remember, this was a 16x. I really should have put that in there. So at the end of this, we have an x as well. So now let's look at the next one. We see that we've got 15 y and what goes into 15? Well, 1 and 15 do. You know that we have to multiply it to y as well. And we also know 3 and 5 do. I'm starting to wonder why I left all that room in between, because those are the only numbers that make up 15. Now I got negative 27. And with 27, I know that I've got 1 and 9, but I'm sorry, 1 and 27 make up, can be multiplied together to make 27. We also know that 3 times 9 will make 27. And now we're looking for all the numbers the biggest number that's in every one of these. And if we see, if we look very closely, we realize 3 is the number that's in all 3 of these that's in common. All right, so that tells me that 3 is the greatest common factor. So B has to be the right answer. Let's check it. 3 times 2x will give me 6x. Very good. And 3 times 5y will give me 15y. Yep, that works. And then 3 times negative 9 will give me negative 27. Yeah, so B is my right answer. Fabian harvests 18 pounds of tomatoes from his garden. He sets aside 2.4 pounds of tomatoes to make spaghetti sauce. If he needs 2 3/5 pounds to make a batch of soup, how many batches of soup can Fabian make? First of all, it says Fabian harvests 18 pounds. That means of tomatoes. That's all he has to work with, the 18 pounds that he has. So I know that's going to be the end result, 18. And we see 18 here. So since it's a possible answer, I know 18 is going to be what everything equals. Next it says he sets aside 2.4 pounds. So that's going to be removed from that 18. So that's part of the problem. Part will be 2.4. That is a possible answer here. So we've checked off that one, and we've checked off this one so far. Now it says he needs 2 3/4 pounds to make a batch of soup. They want to know how many. We don't know how many soups we can make. We don't know how many there are. We use a variable. So that's where that x is over here, is the variable. Now they're going to ask us what goes next to it. Well, I would put 2 3/5, but that's not a possible answer. Everything's in decimal. But I can remember that I can take 2 3/5 and turn it into a decimal. First of all, I know it's got to start with 2. Now I have to figure out what is 3/5. Well, every fraction is a division problem. This is really 3 divided by 5. I have to remember to put my decimal and put my circle here. Now, how many times does 5 go into 30? Well, 6 times. So since the decimal was lined up, that would be 0.6. So now I take that 0.6 and bring it down next to my 2. That gives me 2.6. So 2.6 must be the other answer. Now they're looking for x. How are we going to solve this? Well, it's a 2-step equation, so I'm going to solve it using 2 steps. Let's see, if I have 2.6x, I add it to 2.4. That has to equal 18. First thing I do is move my number, because I got to leave the variable for last, be a negative 2.4. It's the only thing I can combine with positive 2.4 to get rid of it. Whatever I subtract from one side, I have to subtract from the other. All right, now my 2.6x comes down. Remember to line up my decimals here. I have to borrow one from this 8, and that's going to turn it to a 7, this to a 10. So this 10 minus 4 is 6, and 7 minus 2 is 5. And then the 1 comes down. Now I have to divide 2.6 away from x. Whenever I divide from one side, I have to remember to divide from the other. That leaves me the fraction 15.6 divided by 2.6. Let's use our calculator to see how that works. When I do this, I've got 15.6 divided by 2.6. That's going to give me 6. So my answer must be 6. And that completes number 12. Number 13 is a little easier. Solve this equation. 45 plus 5x equals 62.5. Well, this is another two-step equation just like we did a second ago. I will subtract 45 from both sides. Let's see, I'll remember that my 5x has to come down. We line up our decimal. That's going to give me 50 over here. My decimal point comes down. I have to borrow one from the 6 to make this a 12. So that's going to be, let's see, 7. And since this was 5, that turns to a 1. And now 5x has to equal 17.50. I remember that I got to divide 5 away from 5x to get x by itself. Whatever I divide from one side, I divide from the other side. And suddenly I have 17.50 divided by 5. 17.50 divided by 5 gives me 3.5. So let's see, B has to be the right answer. Solve this equation. Well, this is 4 times all the numbers that are inside this parentheses. 4 times 6x is 24x. And 4 times negative 1.2 would be a negative 4.8. You guys will be able to use your calculator, so it'd be pretty easy just to take it out and punch it in, right? 4.12, we'll just make sure that Mr. Mendes got it right. 4 times 1.2, look at that, 4.8, right? All right, so all this has to equal 120. I'm going to get rid of 4.8 by adding it, because it's a negative, right? And the only way to get rid of a negative 4.8 is to add 4.8 to it. Whatever I add to one side, I have to add to the other. Remember, I'm not adding 48, I'm adding 4.8. So I have to remember to line up my decimal. Now that 24x is going to come down. Now the equal sign also comes down. And I have to borrow one from this to get from this 0 to become a 10. So this would become a 1. This would have become a 10, and then I got to borrow 1, makes it a 9. 10 minus 8 is 2. Decimal point comes down. 9 minus 4 is 5. And then the 11 comes down. Now I see I got 24x, and I have to get rid of that 24, so I'll divide it by 24, and it becomes x all by itself. But whatever I divide from one side, I have to be willing to divide from the other side. So this is 115.2 divided by 24. That's going to leave me 4.8. So let's see. So the only possible answer I see is A, 4.8. Let's see. Solve this inequality. We do the same steps for this as we do uh, with our equations, right? So let's just go ahead and work that. 2 times 1.5. That's going to give us, let's see, 2 times 1.5. 3. So we can change this to 3, and then 2 times x will be plus 2x. And that's got to be greater than 13. We're going to borrow, or we're going to get rid of the 3. Let's rewrite it over here so we've got some room actually to do this. 3 plus 2x is greater than 13. All right, we need to get rid of that 3, so we're going to subtract 3 from it. Whatever I subtract from one side, I subtract from the other side. 2x comes down. It's greater than 13 minus 3 is 10. Now we need to get that 2 away from 2x. We'll divide it away. Whatever I divide from one side, I divide from the other. And 10 divided by 2, that's going to give me 5. So x is greater than 5. Each month, the phone company charges $20 for 500 minutes of talk, plus 20 cents for each additional minute. Unlimited texting costs $10 more. Choose an expression to show the cost of talk and texting plan for 1 month, which includes going over 500 minutes. So over here, remember, going over 500 minutes means each additional minute, because this over here said that we're getting $20 for 500 minutes. So we know we're going to pay the $20. Remember, the talking, let's see, shows the cost. That means I'm going to look all for money in here. I'm not going to look for the minutes. I'm going to look for money in my problem. So $20 plus 0.2. Plus 0.2. For each additional minute, we don't know how many minutes we've got, so I'm going to make that x. Remember, when we don't know what something is, we use a variable. And then it says Texting is also going to cost $10. And they want to know a talks and texting plan, so I'm going to have to add 10 to that. Now I combine my like terms. I've got numbers on each side, 10 and 20, so I'll just add them together, and I'm going to make 30. Okay, and then the 0.2x, there's nothing to mix with that. So that leaves me with 30 plus 0.2x. Let's see, that's not right. That's not right. This one, 30 plus 0.20x. And remember, you can have a zero underneath. You can make this 200 or 2000. It doesn't matter. Zeros really don't mean anything. So this is exactly the same as this. All right, which expression is equivalent to this expression? So we're adding expressions. Nothing funny here. We just combine the like terms. I got negative 10a. I'm going to take that 3a and put under it. And since I'm adding everything, that means it stays positive. And then I'm adding 2 over here, so I'm going to add 2b over here. Well, negative 5b plus 2b, that's like I owed you $5 and I paid you back 2. I still owe you $3. And negative 10 plus 3a, that's like I owed you 10 apples and I paid you back 3. That means I still owe you 7 apples. So I should have negative 7a minus 3b over here. Looks like A is the right answer. 18 says, which graph represents this inequality? Negative 6y is greater than negative 30. Let's write that down here. Well, there's a one-step equation or inequality because I can just divide negative 6 away. That leaves y all by itself. And now negative 30 divided by negative 6. Well, I remember a negative divided by a negative is a positive. And I know that 30 divided by 6 is 5. And I also remember whenever I divide or multiply by a negative number, I have to turn my symbol in the other direction. So this is y is less than positive 5. Now, notice it doesn't say or equal to. That means this is going to be an open circle. So it's going to be one of these two. And it says it's less than positive 5, and this is the only one that has a positive 5 in it. So it has to be D. 19, which graph represents this inequality? Well, let's work this one out. We got 3y plus 8 is greater than or equal to negative 7. Well, I know I'm going to subtract 8 from this side, which means I subtract 8 from this side. Remember, we're going to get the variable isolated. I got to get all those numbers to the other side. The only thing I can combine with positive 8 to get rid of it is negative 8. Now I got negative 7 and negative 8. That's going to be combined to make a negative 15. When my signs are the same, I find the sum, which means I'm adding these two together. And then I keep the sign. Now my symbol stays the same. And now 3y comes down. Now I got to get 3 away from 3y. So I'm going to divide it away. Whatever I divide from one side, I divide from the other. Now notice I didn't divide by a negative number. That means I keep that symbol exactly the same. Y comes down. Got rid of those 3's. And now negative 15 divided by 3, well, that's negative 5. So y is greater than or equal to negative 5. Since it could be equal to it, I shade in the dot. So it can be only one of these two. And since it's greater than negative 5, it has to be C. Last one is the greatest common factor this expression. Let's go ahead and look at these. I know that 9 can be made up with 1 and 9. It also can be made up with 3 times 3. So look at the next one. Got 18y. Let's not forget the x over here. Forgot about that. 18, well, that can be made up of 1 times 18. There's also a y there, so put that in there. And it can also be made up of 2 times 9. As well, it can be made up of 3 times 6. Next, we've got a negative 27. Well, negative 27, that can be made up by 1 times 27. Also can be made up by 3 times 9. That's it. So let's go ahead and look for the greatest common factor in all these. Let's see. Well, the greatest common factor I see is 9. So I would say it has to be C. Let's check it though to make sure. 9 times x is 9x. 9 times 2y is 18y. And 9 times negative 3 is negative 27. That's perfect. All right, guys, we went over all the problems. So now you know how to go ahead and work every one of these problems, and you should be ready for the test if you studied them well. Good luck, and I'll see you in class.